Crude oil, often called black gold, is one of the most important substances on Earth. Its significance cannot be overstated, as it plays a crucial role in the functioning of modern society. It fuels our cars, heats our homes, and is used to make countless everyday products. The convenience and efficiency it provides are unparalleled. From plastics and fertilizers to cosmetics and pharmaceuticals, crude oil's derivatives are embedded in nearly every aspect of our daily lives. The versatility of crude oil is truly remarkable. Crude oil's reach extends far beyond the petrol station. It is a cornerstone of the global economy, influencing everything from transportation to manufacturing. Its discovery and exploitation have shaped the modern world, driving economic growth and technological advancement. The history of oil is a testament to human ingenuity and the relentless pursuit of progress. However, this reliance on oil comes at a cost. The environmental and social impacts of oil extraction and consumption are significant and cannot be ignored. Crude oil is a fossil fuel, formed over millions of years from the remains of ancient marine organisms. This long formation process makes it a non-renewable resource, adding to the urgency of finding sustainable alternatives. It is a complex mixture of hydrocarbons, organic compounds composed primarily of hydrogen and carbon atoms. These hydrocarbons are the building blocks of many essential products and fuels. These hydrocarbons exist in a variety of forms, from light, volatile gases like methane, which is used for heating and electricity generation, to thick viscous liquids like bitumen, which is used in road construction and roofing. The diversity in its composition gives crude oil its remarkable versatility. This diversity in its composition gives crude oil its remarkable versatility. It can be refined into a wide range of products, each serving a unique purpose in our daily lives. The extraction, processing, and use of crude oil have profound environmental consequences. The process of drilling and refining oil can lead to habitat destruction, air and water pollution, and other ecological impacts. Oil spills can devastate marine ecosystems, causing long-term damage to wildlife and coastal communities. The cleanup efforts are often extensive and costly, yet the environmental scars can last for decades, while the combustion of fossil fuels releases greenhouse gases, contributing to climate change. The burning of oil and its derivatives is a major source of carbon dioxide and other greenhouse gases, which trap heat in the atmosphere and lead to global warming. As we move further into the 21st century, the need to balance our reliance on crude oil with the urgent need for environmental sustainability has never been greater. The transition to renewable energy sources is not just a necessity, but an imperative for the survival of our planet. The future depends on our ability to transition to cleaner, renewable energy sources. Wind, solar, and other renewable energies offer a path forward that can reduce our carbon footprint and mitigate the impacts of climate change, while mitigating the environmental damage caused by our dependence on this finite resource. Efforts in reforestation, conservation, and technological innovation in renewable energy are crucial steps towards a sustainable future. The journey ahead is challenging, but the stakes are too high to ignore. Our collective actions today will determine the health and well-being of future generations. Crude oil, in its raw, unrefined state, is a viscous, black liquid. This thick, dark substance is often referred to as black gold due to its immense value and versatility. It is the lifeblood of modern civilization, powering industries, transportation, and heating systems across the globe. Its color and viscosity can vary depending on the specific mix of hydrocarbons present. Some crude oils are light and almost amber in color, while others are so thick and dark that they resemble tar. This variation is due to the different types and proportions of hydrocarbons and other organic compounds found within the oil. These hydrocarbons, the building blocks of crude oil, are formed from ancient organic matter subjected to intense heat and pressure over millions of years. This process begins with the remains of microscopic plants and animals that once thrived in ancient seas. As these organisms died, they settled on the sea floor, becoming buried under layers of sediment. The precise composition of crude oil varies widely depending on its source. Oil fields in different parts of the world produce crude oils with unique characteristics. For example, crude oil from the Middle East is often rich in sulfur, while North Sea crude is typically lighter and sweeter. These differences affect how the oil is processed and what products can be derived from it. The most common hydrocarbons found in crude oil are alkanes, alkenes, alkynes, and aromatic hydrocarbons. Each of these types of hydrocarbons has distinct properties and uses. Understanding their structure and behavior is crucial for refining crude oil into useful products. Alkanes, also known as paraffins, are saturated hydrocarbons, meaning they contain only single bonds between carbon atoms. This makes them relatively stable and less reactive compared to other hydrocarbons. Alkanes are a major component of gasoline and other fuels. Alkenes, on the other hand, contain at least one carbon-carbon double bond, which makes them more reactive. This reactivity is useful in the production of plastics and other synthetic materials. Alkanes are key intermediates in the petrochemical industry. While alkynes have at least one carbon-carbon triple bond, this triple bond gives alkynes unique properties, making them valuable in specialized chemical processes. They are used in the synthesis of various organic compounds and materials. Aromatic hydrocarbons, characterized by their benzene ring structure, are also important components of crude oil. These compounds are known for their stability and are used in the production of dyes, detergents, and pharmaceuticals. The benzene ring structure is a fundamental building block in organic chemistry. This complex mixture of hydrocarbons gives crude oil its remarkable versatility. From fuels to plastics and from pharmaceuticals to cosmetics, the products derived from crude oil are integral to our daily lives. The refining process is essential to unlock the potential of this natural resource. Different hydrocarbons vaporize at different temperatures, allowing them to be separated and refined into various fuels and other products. This separation process is achieved through fractional distillation, where crude oil is heated and its components are collected at different boiling points. This process, known as fractional distillation, is a cornerstone of the petrochemical industry. It enables the efficient production of a wide range of products, from gasoline and diesel to jet fuel and lubricants. The ability to refine crude oil into these diverse products is what makes it such a valuable resource. The use of petroleum, in its various forms, dates back millennia. This versatile substance has been a silent companion to human civilization, evolving in its applications and significance over the centuries. Ancient civilizations, from Mesopotamia to Persia, used naturally occurring asphalt, a thick, sticky form of petroleum, for waterproofing, construction, and even mummification. These early uses were crucial for the development of infrastructure and preservation techniques. The waterproofing properties of asphalt allowed ancient builders to create more durable structures, while its preservative qualities were essential in the mummification process, ensuring that the deceased were prepared for the afterlife. However, the modern oil age began in the mid-19th century with the drilling of the first commercial oil well in Pennsylvania, USA. This groundbreaking event, led by Edwin Drake, marked the beginning of a new era. The success of this well demonstrated the potential of oil as a major energy source, setting the stage for the Industrial Revolution and the rapid technological advancements that followed. This event marked a turning point in human history, ushering in an era of unprecedented economic growth and technological advancement. The availability of oil fueled the engines of industry, powering factories and machinery that transformed economies and societies. The Industrial Revolution, driven by the newfound energy source, led to mass production, urbanization, and significant improvements in the standard of living for many. Edwin Drake's successful drilling in 1859 unleashed an oil boom that quickly spread across the globe. Towns and cities sprang up around new oil fields, creating bustling communities centered on the extraction and processing of this valuable resource. The oil boom not only transformed local economies but also had far-reaching impacts on global trade and industry. The invention of the internal combustion engine in the late 19th century further fueled the demand for oil, solidifying its status as a strategic commodity. This technological breakthrough revolutionized transportation, making it faster and more efficient. The internal combustion engine became the backbone of modern vehicles, from cars to airplanes, and its reliance on oil ensured that petroleum would remain a critical resource for decades to come. The automobile, powered by gasoline, a refined product of crude oil, revolutionized transportation, transforming societies and landscapes. The widespread adoption of cars led to the development of extensive road networks, suburban expansion, and changes in lifestyle. Gasoline stations became ubiquitous, and the car culture became a defining feature of the 20th century, influencing everything from urban planning to social dynamics. The 20th century witnessed the rise of powerful oil companies, the formation of international cartels like OPEC, and numerous geopolitical conflicts fueled by the pursuit of this valuable resource. Oil became a central factor in international relations, with countries vying for control over oil-rich regions. The influence of oil extended beyond economics, shaping political alliances and conflicts, and playing a crucial role in global power dynamics. The two world wars in particular highlighted the strategic importance of oil in modern warfare. Control over oil supplies became a critical factor in military strategy, with nations striving to secure access to this vital resource. Tanks, planes, and ships all relied on oil, making it a key determinant of military capability and success. The wars underscored the necessity of oil for national security and global dominance. Today, despite growing concerns about climate change and the need for renewable energy, crude oil remains the lifeblood of the global economy. Modern society is deeply intertwined with oil, from transportation and industry to everyday products like plastics and pharmaceuticals. However, the environmental impact of oil extraction and consumption has led to a growing movement towards sustainable energy sources. Wind, solar, and other renewable technologies are being developed and implemented, aiming to reduce our dependence on fossil fuels and mitigate the effects of climate change. The transition to a more sustainable energy future is a complex and ongoing process, reflecting the enduring significance of oil in our world.